Higher volts means higher amps. I have to repetitively talk about that on my page because so many people get it backwards. I understand what the confusion is. The confusion comes in when you start factoring in watts. But straight up volts resistance, higher volts means higher amps. Rather than argue, I've set up a demonstration. We're going to run it and see what happens. I have this receptacle wired for 247 volts. I have this receptacle wired for 123 volts. I have a resistive load that is a hot plate. I have a sump pump. The hot plate is rated at 120 volts and 1800 watts. I plug in the hot plate, 14.3 amps, running regular. We have the same hot plate. This time we have 247 volts, 28 amps. She's making some funny noises, but there you go. For the 120 volts, we had 14.3 amps. For the 246 volts, we had 28 amps. Double the voltage, double the amperage. The thing is, the watts are not the same. This has 1687 watts. To figure the watts over here, we take the 28 amps and multiply it by the 236 volts. Equals 6,608 watts. You double the voltage, you double the amperage, but you quadruple the wattage. That is why 240 volts has the ability to deliver more power for less amps. To get this amount of watts at 120 volts would take more than 28 amps. But if you're just looking at the resistance and the amps, increase the volts. Make sense? So while that proves my original point, I usually get, yeah, but it's different for motors. So now I'm going to plug a motor in and see what happens. For reference, that's the stats on the motor. I plug in the motor to 120 volts. 1.07 amps. Okay, now I'm going to plug the same motor into 246 volts. I was tempted to do this as a riddle because I don't think anybody would get this right. Well, not anybody, that's an exaggeration. There's some really smart commenters. But watch what happens when I plug it in to 240 volts. I've never let it run long enough to see when that stabilizes because I'm afraid of burning out my motor. But yeah, we can certainly say the current didn't go down, right? And I know you've had tons of experience with motors giving you different results in real life. It's because the motor or the equipment is not the same. Here's a 100 watt, 120 volt heat lamp. Here is a 100 watt, 240 volt heat lamp. They're not the same. The resistance on the 120 volt one is 149 ohms. The resistance on the 240 volt one is 297 ohms. In order to get that effect where you see the current drop when you buy the higher voltage for the same wattage, you're not buying the same equipment. That's why on motors, you have to move the tabs or hook to different wires or different leads or whatever. And basically you have two windings. And at one voltage, they're in series, and at the other voltage, they're in parallel. That's how one motor can do two voltages. And I know there is some lights that we use that can be dual voltage. And I think that's just the electronics guys being wizards of how that light can internally be a smart thing and switch over what it needs to run at both voltages. I would love an electronics guy to explain that to me. But it's still, if you don't change the resistance, you increase the volts, you increase the amps. That simple. Thank you very much.